Homework on general solutions, trig equations. Solve for alpha. Type? Why? Because I have to factorize. There's no way of any other type happening. So I'm factorizing, taking out a common. 10. What's left? Sine alpha minus 1. Then the principle from algebra equations. When I multiply and the answer is 0, then either tan alpha is 0 or 2 sin alpha is 0. So that would mean that the 1 goes across and becomes a 1, and then I divide it by 2. Then this is a type 1 and a type 1. Out of this one you can get 2 answers, but we're going to make it 1 because it's tan, right? And out of this, you're going to get 2 answers as well for your general solution. You've got to help me here. So then the reference angle, and you should know that from your graphs, is 0. Tan is then, what is 0? What is 0? Is it positive or negative? Positive. We decided to check it as positive. But because it's tan, we're only going to look at the first quadrant. Angle's name is alpha. So our angle is 0 plus k times 1, 80. Many people will just write k times 180. You don't need the 0. Because then the first time that you put in 0 for k, your answer will be 0. And then you're going to add, and subtract the 180s as well. And then you just need to write k's somewhere in this sketch, in your sum. For that one, you're going to have reference angle of 30 degrees. Your sin ratio is positive, so it's first and second quadrant. For first quadrant, we write alpha is 30 plus k times 360, we're done. For the second quadrant, we write alpha is 180 minus, you've got the pattern going now, 30 plus k times 360. So we've got 150 plus k times 360. And if somewhere I've written k's, I'm done. If I had to do specific solutions, it would be 0, add 180 minus 180. It's 30 plus 360 plus 360 and minus 360 minus 360. 150 as well, plus 360 and minus 360 to get a set. But that would be specific solution. If I told you that alpha was, for instance, between minus 270 and plus 180, then you would just make sure your specific solutions lie there. Again, a general solution. Type? Well, at the moment, no type. I've just got one thing to do. It's not even a type. You've just got to take the tan and make it sin over cos. And then the cos will fall away, and I'll be only left with, which is a type 1 sum, not even type 4 here. So we've got to get our reference angle, and the reference angle is 36.87. And I'm busy with positive sin, so again I'm in quadrant 1 and quadrant 2. Quadrant 1, angle's name theta is 36.87 plus k times 360. Or in my second quadrant, my theta would be 180 minus 36.87. And can you give an answer for that, please? 1 plus k 360 and k's, and my sum is done. General solution. Okay, solve for x. Trigonometric equation, it's a k sum. Which type? Whether you say 2 or 3, I don't care. It's the one where it's sin and cos, and the same angle means I have to divide by cos. So if I say divide by cos and divide by cos, because the angles are the same, then this can be, and it's equal to 2. So we have type 1, and the reference angle is 50. 63.43. I'm busy with a positive tan ratio. That's why in the quadrants I'm busy with the first and third. I don't write the third because you know we write k times 180. So for quadrant 1 it will be x. The name of the angle is 63.43 plus k times 180, and the sum is done. How many marks? 3. Maybe 4, 3. Okay? Because it's spelled the dividing by cos, reference angle, answer, maybe there's a mark for cares or maybe not, 3, maybe 4 marks. Basic. This one's got a lot more higher level quality to it. It's definitely type 4. Are you with me? Keep in mind that if it's necessary, you can always change a 1 into 1. Sin squared plus cos squared. What would minus 1 be? Minus sin squared. Minus cos squared. You better put the stuff together now. Get your very good mathematical brain into action. Alright, but this is definitely type 4. Because the moment that there's more than 2 terms, it's got to be type 4. Factorization. What type of factorization is this? Quadratic trinomial. It helps you if you want to go do a little bit of a K method. But quickly in your mind, that must become natural for you to do it like that as well. So you've got your factors of 2 and your factors of 1. We're still going to be doing it the same old way. And then to get what? Positive 1. Remember, we're treating sin theta like it's a variable. So it'll be positive 1 if I use my signs like that. So it'll be 1 plus 1. 1 what? And 2 minus 1. So this must be K now. You still were in the K method, but here it must be sin theta times sin theta giving me sin squared theta. So this would be sin theta is equal to negative 1. This one will work out to sin theta is equal to positive a half. Do you see how many times those special angles come in here? Sin theta being a half is going to make it the reference angle of 30 degrees. But you've got to calculate, no problem. But remember, you should actually supposed to know it. So for this one, they both of them now type 1. Sin is equal to 1 for reference angle, 90 degrees. But sin is negative. So I'm in the third and fourth quadrants. So for the third quadrant, we write angle's name, theta, is 180 plus the 90, plus K360. For the fourth quadrant, we've got theta is equal to 360 minus 90 plus K360. And both of them are 270 plus K360. Does that matter? It's exactly the same thing, like in algebra when we have x is 3 or x is 3. And don't forget your cares sooner rather than later and you forget. This part of the question then has a reference angle of 30. We are in the first and second quadrants because sin is positive. Therefore, in this first quadrant, you'll have theta is equal to 30 plus k times 360. In the second quadrant, we've got theta is equal to 180 minus, which gives me 150 plus k 360. And don't get lazy and want to leave all of this stuff until later. You've got to write it all right from the start. So our answer for that one is, and now we've done our key sums. Right. The last bit of trig for the term, because it's not the last trig for the year, you still need to solve triangles with new formulas, but that comes later in term 3. For these identity things, when we say prove that left-hand side, right-hand side, we never came to this specific question because we hadn't done cares yet. We had to do all the identities and reduction formulas. Now I can ask you, now I can go back in those questions and say, prove that it is. I'm not saying that we've done that. Prove that it is, but now I want to know for which values of theta will this be undefined. Did we do stuff like that in algebra as well? Yes. The moment I ask you when is it undefined, what am I asking? When can the denominator be 0? When is it undefined? It's the exact same thing. So it'll be undefined if sin squared theta is equal to 0, or if 1 is equal to cos. Are you getting my drift? If 1 minus cos theta is equal to 0. Where's the rest of the sum here? We're making a statement that if it's going to be undefined, it's got to be something underneath the line, nothing with the top. So that must be 0, or that must be 0. And what type of a sum is this? It's K's. Are you with me? It's K's. Now with the square, what do? We square root, and normally we say plus minus, right?
Yes.
But it's 0. In any case, what is 0? Is it positive? Is it negative? We're going for our positive assumption. And we're going to write for quadrant, first of all, please, what's the reference angle? Is 0. For first quadrant, it will then be theta is 0 plus k times 360. And for the second quadrant, it will be theta is, which is still what? 80. And you can combine these two, be smart, be whatever. Just leave it like that. Before we forget, let's not forget to write Yes, because this is what, when this will be equal to 0 and this whole thing will be undefined. Or, when 1 is equal to cos, that's also a type 1. Meaning that 1 is equal to cos for reference angle, 0. And I'm in the which quadrants if cos is equal to positive? First and fourth. So for that, first quadrant, theta is equal to 0 plus k 360. And for the fourth quadrant, theta is equal to 360 minus 0 plus k 360. You've actually got this answer inside of that one. But don't even overthink it, just write down both of those answers. And again, the key is if you want to write it twice or 4 times, it's okay. But once is fine. This is when that will be undefined. Like for instance, if theta was 360, and you go to your graph of 360, if you go to 360, then this will be equal to 1. Think about it. And if it's 1, 1 minus 1 is undefined. What were we trying to find? The values that this makes this identity undefined, and that's exactly that. All right. Another one. There's no denominators. So when will this be undefined? If I ask you when it will be undefined, it should be, eh? I won't ask when will it be, and there's nothing. But there's no denominator. Tan is actually sin over cos, but more than that. Tan has problems, all of its own. Tan is a mind case because it's got asymptotes. So if you had 90 in your theta, the sum falls apart because tan 90 does not exist. It's undefined. So if ever you are in a sum and I ask you when will it be undefined, if there's a tan in it, whether there's a fraction or not, you've got to state tan cannot be equal to that denominator. So tan is undefined. And this will always be something that you're going to be writing. Tan will be undefined if tan theta is equal. Tan theta will be undefined. Always, always, always. Will be undefined for theta equal to 90. Do you agree?
Yes.
Are you seeing the graphs? 90. But what about all the others? Because then you get to 70, etc. And you're going to get to minus 90, etc. So this is like a pattern, a given study work. This will always be the problem for tan, if that's the value. And it's still test. That's it. Sum done. But the moment that you have a denominator, you've got a problem if the denominator is 0. Even if there is no denominator, you've got a problem if there's a tan. So you must make sure tan does not become undefined, that it's not on its asymptotes. The asymptotes being 90, and then every 180 and minus 180 because of the period, that will also happen. Does it make sense? This had been a sum question. How many marks?
2.
Maybe 2. I think 2. Maybe not just 1. That's a little bit too little. For which values of theta will this be undefined? So obviously everybody knows sin theta equal to 0, and then we do our little type 1 case sum. But also for tan is undefined if not tan equal to 0, that's not a problem. Not where tan is equal to 0. But tan itself is undefined for what? 90 plus? You see that you're always going to be writing this. Say, for instance, that had been a 2 theta. Then you would have had tan 2 theta is, where 2 theta is. And then you would have divided everything, because now it's going to be every 45, because it shrank. Okay? And then this one is complete the type 1. Reference angle, 0. There's so much that you're going to know this by heart. First and second quadrant, so it's going to be theta equal to 0 plus K90. K90. Or, second quadrant, 180 minus 0 plus K360, which is just 180 plus K360. What's wrong? Thank you. Okay, maybe they would ask you in the, maybe it was a tan graph that you had to go and sketch, or sin and cos and tan graphs, and they only issued it from minus 90 to 270, and they're asking you this question. Then you just go into that interval as well. Not specifically asked, but it's on the sketch that you're only working from there to there. So those are the undefined sums. That's it, guys. It's actually doing a little bit of cares inside of your left-hand side, right-hand side, if it's asked there. But it can be asked on its own, like I've done here.